Okay, Assalamualaikum and hello everyone. So now I'm going to teach what is mutual inductance. Okay, so the first learning outcome for mutual inductance is define. Define mutual inductance. Okay, so what is mutual inductance? Mutual inductance is a phenomenon, okay, there are satu fenomena by which a changing of electric current in a coil produce an induced EMF across the other coil. Okay, what does it mean is, for example, you have two coil. For example, you have coil 1 and coil 2. Okay, contohnya, bila current in coil 1 change, maksudnya bila ada perubahan current pada coil 1, magnetic flux dia juga akan berubah. Dan perubahan ini akan dirasa oleh coil 2. Jadi, dia akan induce EMF dekat coil 2. So the induced EMF in coil 2, we will write it as induced EMF in coil 2 equals to negative mutual inductance darab dengan rate of change of current in coil 1. And it's vice versa, the same thing happen. Okay, for example, if there is change of current in coil 2, okay, for example, there is a change of current in coil 2, the magnetic flux will also change. So bila dia dah change, dia akan di-experience oleh coil 1. Okay, these changes akan experienced by coil 1, di mana coil 1 pula akan induce EMF. Okay, so that's why we will get the equation EMF at coil 1 equals to negative mutual inductance darab dengan rate of change of current. So if you got the changes of current, dia akan ada magnetic flux change. So when you got the change, for example dekat coil 2, current changes, magnetic flux akan berubah dan dia akan induce EMF dekat coil 1. Sama juga, kalau dekat coil 1, current berubah dan EMF berubah, current berubah dan magnetic flux pun berubah, dia akan induce EMF dekat coil 2. Okay, so that is mutual inductance. Alright, so that's why mutual inductance tu kita akan tulis dia sebagai EMF. For example, EMF 2 equals to negative M, which is mutual inductance darab dengan rate of change of current in coil 1. And kalau induce EMF dekat coil 1, dia akan sama dengan mutual inductance darab dengan rate of change of current in coil 2. So when we rearrange, you will get this equation. So mutual inductance will equals to EMF in coil 2 divided by rate of change of current in coil 1 and equal to EMF in coil 1 divided by rate of change of current in coil 2. So mutual inductance is defined as the ratio of induced EMF in a coil to the rate of change of current in another coil. So nampak tak? So contoh EMF dekat EMF of coil 2, rate of change of current dekat coil 1. And dia adalah scalar quantity, which is dia cuma ada magnitude. And the unit is Henry H. So that is mutual inductance. So we also can write mutual inductance as magnetic flux linkage through coil 2 darab dengan number of turns of coil 2 divided by current 1, current in coil 1. Or kita boleh tulis juga sebagai number of turns in coil 1 darab dengan magnetic flux linkage through coil 1 divided by current in coil 2. So that is mutual inductance. So the definition of mutual inductance is process of producing an induced EMF in one coil due to the change of current in another coil. Contoh, kalau EMF 1, perubahan dia adalah dekat current 2. Kalau EMF 2, perubahan current dia adalah pada coil 1. Okay, that's why. Okay, for example, this is coil 1 and this is coil 2. Now, the learning outcome is use mutual inductance between two coaxial solenoids. So we're going to use the formula. So like I told you, if we're going to get the induced EMF at coil 1, the rate of change of current will happen at coil 2. And then EMF at coil 2, induced EMF at coil 2 is due to the change of current in coil 1. So awak akan dapat awak punya mutual inductance equals to negative EMF2 divided by rate of change of current in coil 1 equals to EMF1 divided by rate of change of current in coil 2. Okay, so this is for coil. Alright, now let's see what if it's for two coaxial solenoids. Okay, ini adalah untuk coil kan. So let's see for two coaxial solenoids. What does it mean by two coaxial solenoids? So untuk two coaxial solenoids, we will have two coil. Okay, so for example, the black color coil is the first coil and the orange color coil is the second coil. So we will have the number of turn for coil 1 and number of turn for coil 2. So for two coaxial solenoids, alright, the formula will be M equals to mu naught N1 N2 times the area divided by the length. And this is going to be the length of the solenoid. Okay, ini adalah length of solenoid. Okay, so as we know, another definition of mutual inductance is ratio of induced EMF in a coil to the rate of change of current in another coil. And it also can be written as, for the magnetic flux, for the mutual inductance, the formula also can be written as number of turns in coil 2 times the magnetic flux linkage through coil 2 divided by current 1, and also number of turns in coil 1 divided by the magnetic flux linkage through coil 1 divided by current 2. So now you will have three formula. Alright, so this is for the two coaxial solenoids, the formula, and this is for the coils. Okay, that's all for mutual inductance concept. Okay, now let's look at example 9. Okay, the question says primary coil of a cylindrical former with the length of 50 cm. Okay, so the cylindrical former is the length of 50 cm. So this is the case for two coaxial solenoids. Okay, two coaxial solenoids. Case dia lebih kurang macam two coaxial solenoids. But if you got two coil, yang akan turn dekat cylindrical formers tu lah. And then the diameter is 3 cm. This is the diameter, and dia akan ada 1000 turns. So 1000 turns is for the primary coil. So I will label this as N1. And the secondary coil akan ada 50 turns. So for secondary coils, I will label it as N2. So the first question asks us to look for the mutual inductance. So as like I told you, this is two coaxial solenoids, meaning you have two coil that lilit dekat cylindrical former tu. So the mutual inductance will be mu naught, formula is mu naught, number of turn of coil 1, number of turn of secondary coil, times the area divided by length. So we know mu naught is 4 pi times 10 to the power of negative 7. Number of turn for primary coil is 1000. For secondary coil is 50, and area. So how do you find the area? Area is pi r squared. Okay, pi r squared. Now we only have the radius. We only have the diameter, but we can find the radius. So radius equals to diameter divided by 2, which you will get 1.5 centimeter. So it's going to be pi times r squared. So 1.5, I will convert it into meter squared, and divided with the length. So the length of the cylindrical former is 50 centimeter. So you will get your mutual inductance 8.88 times 10 to the power of negative 5 Henry. Okay, that's for A. Okay, now let's look question B. This question says the induced EMF in the secondary coil. So we are going to find for EMF2. If the current flowing through the primary coil is changing at the rate of 4.8 ampere per second. So rate of change of current for primary coil is 4.8 ampere per second. So we know mutual inductance, we can use this formula. Mutual inductance equals to induced EMF in secondary coil divided with rate of change of current in primary coil. Mutual inductance we already got from A, the value, which is 8.88 times 10 to the power of negative 5. And we are looking for the induced EMF in secondary coil. And we know the rate of change of current in primary coil is 4.8. So you will get your EMF in secondary coil 4.26 times 10 to the power of negative 4 volt. That's all for mutual inductance. Okay, thank you.